We're here at WEFTEC, Lagoons Do Better TV. We're going to talk to SCAN about instrumentation, monitoring of key parameters for lagoons. So I got Brendt Thompson here from SCAN. So Brent, talk to us about the type of parameters that we could utilize in a lagoon system to help monitor the water quality.
Sure. So the beauty about SCAN is all of our technology is reagent free. So that means that we have the least amount of maintenance possible when in the field. And our core technology is spectrometry.
Okay.
So it is a UV vis spectrometer probe that's capable of measuring up to 8 parameters simultaneously.
Okay.
TSS, COD, BOD, nitrate, nitrite.
BOD, eh?
BOD.
So how do you do that?
BOD is done optically. So when we're looking at a spectrum, we're measuring from 190 nanometers to 750 nanometers and 256 different wavelengths within that range. And BOD absorbs somewhere in the UV range, somewhere between 250 and 360 nanometers.
Sure.
And it's somewhere in between the turbidity compensated spectrum and your raw spectrum. So there's this little spike that comes up above that UV spectrum, and there's a very distinct point where BOD absorbs.
Oh wow. So how accurate is that?
Yeah, BOD can be very accurate. It depends on your water quality matrix in most places. Depends on your industrial influence, but we can be somewhere in between plus or minus 5% of a lab value.
Cool. Well, talk to me about some of these other probes you got.
Great. We also have ammonia sensors that use a fairly standard ISC technology. This technology is based around a very stable, long-lasting reference electrode. This is a solid state reference electrode. That means that there is no salt bridge. There's nothing that's actually leaking out of the electrode, which makes it really stable at a long-term life cycle. We specify this down to 0.2 milligrams, 0.02 milligrams per liter, and upwards of 1,000 milligrams per liter in an aeration basin or in some kind of a lagoon system.
So with that probe, what's the output? Is it going to tell me NH4, NH3?
Sure. Since we're measuring the ion, it's an NH4. So we're measuring we need the ammonium ion to actually absorb into this electrode. So this electrode or this system is actually a multi-parameter system. We would have potassium compensation, ammonium, nitrate, or pH, and NH4.
Okay. Can you then convert that NH4 into NH3? Is there a way to figure out what that is? Because a lot of the limits we're seeing on lagoons is NH3.
Absolutely. So by using pH and temperature and NH4, it's simple chemistry to give you a derived NH3 value. Okay.
Cool. What about this last one over here? Is that?
Yeah. So this is an iScan. So this is something that we launched about 2 years ago. It's a low-cost spectrometer. The difference between these two probes is the light source that it actually uses. So this is a xenon flash lamp. And this is a LED flash lamp. Right? So it's using multiple LED light and passing through the sensor to generate TSS, COD, UV254, and color. And what's really interesting is that the TSS measurement is a dual wavelength measurement. We can do a 90 degree or a 180 degree scatter.
Sure. So why would we use this probe versus that probe? Where do they fit?
So the difference here is the wavelengths that we're actually measuring. Because this is using a xenon flash lamp, we can actually go down to 190 nanometers. LED light sources only go down to about 250 nanometers, which eliminates a nitrate or nitrite measurement. So in order to measure nitrate and nitrite, you need to get down to about 200 and 220, which LEDs just don't go there yet. So this is a low cost. Your resolution is going to be a little bit less, but in a lagoon system, it's going to give you the data that you need for COD.
And I assume this is a little bit lower cost, like you said?
It is. It is a little bit lower cost. And you get less parameters. This is up to 8 parameters, and this is only 4 to 5.
What about O&M on these types of probes? What has to be done on a regular basis, and how much does it cost? Give us some ballparks on that.
So the spectrometers have no reagents. There's no consumable parts. There is nothing that actually wears out on these. This is actually a dual wavelength in here. So the light source travels across the path length and below the path length. So we're actually auto-compensating for the degrading or the aging of the light source. So there's nothing in this probe that will ever have to be replaced in an estimated 10-year life cycle. The ion selective probe does use electrodes, which means that this probe does need to have the electrodes changed every
Okay.
6 to 12 months, depending on your water quality matrix. In most cases, it's going to exceed that 12-month life cycle.
Okay. Cool. And this guy, same deal as this?
Same deal as this.
Okay.
And I guess I should mention that all of our probes come with automatic cleaning. So if you have this in a Lagoon system, it's using air to clean these sensors real time so that you don't have any kind of operating maintenance or hands-on to actually pull the probe to clean it. It's doing it automatically for you.
Okay. Cool. Was that air purge or how does it work?
We offer a few different techniques. We offer an auto brush for this, depending on your water quality, but in most cases in a lagoon, you'd likely use air. And the thing about air is that we're not using the air to clean the sensors, we're using the solids within the water pushed by the air to clean. So we're creating a sandblast effect, right?
Okay.
So it's using the solids to,
That's cool.
to rub against the windows to keep them clean.
Sure. One of the other cool things that we like about the SCAN system and what caught our eye was the ability to monitor and to also communicate that wirelessly. So can you show us your controller, how it works, what it looks like, that kind of thing?
Absolutely.
So this is your Concube system.
Yep.
This is where you feed the probes into this thing. Show us around a little bit, show us how it works and why it's a cool technology.
Sure. So first let me say this is more than just a terminal, your everyday terminal. This station is actually an industrial PC. It can hold up to 250 parameters theoretically, but in most cases we don't see that many. I think the most I've seen is around 64. What's neat about this is it's fully online. This is a Linux-based platform, but beyond that we're using Firefox Windows browsers as our operating or our touch screens. Cool. What's cool about that is that if you pull up this IP address on your phone, this is exactly what you're going to see. So you're going to see exactly this screen.
That's awesome.
You're going to have all the functionality and all the capabilities as if you're standing right in front of this computer. So you can look at time series data, you can look at alarms, you can calibrate the sensor, you can do everything as if you're standing right here.
You can calibrate the sensor?
Absolutely.
From the controller?
Absolutely.
Can you do that via your phone too?
Absolutely.
Wow.
SCAN has an application that is actually linked directly to this. So you can do it via an IP address or you can have your own app on your cell phone. You can do it on an iPad. You can do it on your computer, on your laptop, whatever you'd like.
Can you set up alerts and things like that?
Sure. So SCAN has proprietary software for an alarm system called Anatool and Valitool. It's data validation and event detection. And this is really important when we're looking at process control, to control blowers for aeration or to control mixers or anything like that. It actually looks at data and validates your data based off of what it expects to be a real value. So we clicked on one of the sensors or on one of the parameters. We're going to look at and see two different lines here, the red line and the blue line. The red line is your cleaned data. The blue line is your raw data. So you can see the raw data has a little bit of noise in it. The red line smooths out that raw data and gets you a nice, clean, validated trend line, which is really important when we're looking at alarms. So if there's an upset in your process, if one of your aeration blowers goes off, if something happens and you need to know about it, you can have an alarm triggered by this data, this validated data, and have an SMS sent to your text to your mobile phone for a real-time alert.
Cool. Hey, what else about this? Can you tell us about this? Where else do you think you see it being used?
Sure. So another thing that's really interesting is that all our sensors are smart technology. So as you see here, this flashing status light, it's actually indicating that there's an issue with your station. And if you look at the red lights here, there's indication that each of these sensors are having some kind of problem. You click on the sensor, it'll take you to the status, and it tells you that right now the sensor's okay. It's runs self-diagnostics, and it knows that sensor's okay. There's no issues here. But what there is an issue is there's parameter error. There's something wrong with the installation. In this case, there's no water going through the station, so it's notifying you that there's an issue here. There's no water. There's something that the wrong medium.
Right.
So so all the sensors run self-diagnostics so that if you have an issue, and this is a remote site, and you can look in real time, you can have an error, and you can see, I've got an issue with my sensor, or I've got an issue with my installation.
Cool. So how do you see people using instrumentation? Your typical customer on the wastewater side. What are they doing, and what are the cooler things that they are doing that you're setting up and selling instrumentation for?
So some of the neat things that we've recently seen is industrial contamination, right? Okay. So we're looking at people have this in the collection system, monitoring for any kind of industrial spill or industrial dump so that their treatment plant or lagoon can be prepared for something coming into their facility.
Sure.
Another thing that's really neat is ammonia-based deal control. So we have some energy savings or cost reduction in running our blowers off of an optimized speed.
Sure.
And then also we're looking at getting away from that old technology where we have reagents and we have a lot of products that are no longer, maybe the spectrometer has been around since 1999, but it's only lately have we seen it really become more mainstream and used in a real-time installation. We're getting away from the reagents and the chemical addition, and going towards something that's cost-effective and has a long-term success life.
And a lot easier to use.
And a lot easier to use. Absolutely.
I've done ammonia tests using a colorimeter, and it's a hassle.
Absolutely.
It's a real hassle.
Absolutely.
And to have an instrument that can tell me instant real time without me really having to do anything, and it kind of self-maintains itself, is huge. And it can make the difference between breaking permit or not breaking permit.
Absolutely.
And that's what we're talking about here.
Absolutely.
And that's what these kinds of alerts. I thought that was interesting. We were talking about industrial users. A lot of lagoon systems have pre-treatment agreements with industries in town, and I've heard horror stories about that industry will send something down the pipe at 3 in the morning when they know, of course, nobody at the plant is prepared for that, and kill off all the biology in the lagoon because they just overload it. If you had something like this in the pipe ahead of that, you could shut the valve off, ahead of time, get an alert, and shut the valve off so they couldn't actually just,
Well, what's awesome is that this controls all of that, right? You can have this control a valve, you can have this real-time send alert to your phone, so if this happens at 3 a.m., your spectral alarm will go off. It'll say, hey, you've got an issue in your stream coming down your line. It'll close the valve automatically for you. It'll run an auto sampler.
So you can set it up to do that?
Oh, yeah, sure.
Okay.
Not only can it shut the valve, but it can also trigger an auto sampler, so it pulls that sample for you, so you can take it to a lab and really prove what it is.
Yeah,
but beyond that,
awesome.
We have forensic evidence based off the spectral alarm of what that is, because we're quantifying in a raw digital format what your water quality is, and everybody has a fingerprint, same as a chemical compound. Every chemical compound is different. We know what that chemical compound was that came down your pipeline based off of that spectral signature.
Oh, wow. That's amazing. That gives towns a real lot of power, because I think it's very difficult from a pre-treatment point of view when you have that kind of agreement. Those industries that are not in the wastewater business, and you got to still make permit at the same time. And having that kind of information allows you to prove something and to apply the fines necessary in order to get paid if they're gonna violate. Which is really cool. So, well, thanks, Brent. I really appreciate it. Good chat today.
I appreciate it.
Have a good one. Go to Lagoon's Do It Better campaign that we're doing. If you go to tpenv.com/LDIB, you can register. And if you register for our YouTube channel, our Facebook page, and for our blog, we'll send you a free hat. So, camo hats galore.
Excellent.